Okay lads, so this is the 2017 Junior Cert question on transformation geometry. So as you can see there, I've set up the initial view and all the points. So I just want to go into this here and just explain what I've done. So for the initial setup, I've measured in 160 millimeters from the left and 160 down from the top there to give me point P. When you look at the diagram there, you can see that this inside circle has a diameter of 56 millimeters. So that's a radius of 28. And you draw this circle here. Then you stretch out the radius to 40 to get this arc here, and then up 20 and down 20 to get this bit here. And you see from the diagram there that if you let this 20 line come in here to intersect the vertical line, you join that down to P, and then this is 90 degrees and you get this bit here. So you set up that view there, and then once you've done that, go and find the other points accurately. So after the setup of the question, the first thing that the question asks us to do is to move the image from P to P1 by a central symmetry. So we have to find the point of symmetry. To do that, you join from P to P1 with a line. Then using your compass and a distance of greater than half the line, you swing an arc from P1 above and below the line, and then you put your compass on P and you swing another arc above and below the line. Where the arcs intersect, we draw a line down across here, and that gives us the midpoint of P to P1, which is Q, and this is the point of symmetry. It's also going to be useful to have another couple of points labeled that we can track as it moves through the view. So the center there is obviously important, and I'm just going to call this point here the end of the spanner A. So I have those points that will help me when I'm tracking it through the views. So that's the first part of the question, to find the point of symmetry, and we've just completed that there. So lining up your set squares with Q, the point of symmetry, bring A and C through Q and out the other side. So with your compass on Q and opened up as far as C, swing that distance to the other side to mark the position of C1. Then swing back the compass, open up as far as A, and again swing the point A onto its own projection line. And as a way of just making sure that you're accurate, down here A, C and P are all on one line. So up here P1, C1 and A1 should. So once you've brought all the points through Q, the point of symmetry, and the distance that they travel to Q is the same as they travel out the other side, you should end up with a situation where P1, C1 and A1 are all on the same line. So once you have this done, then you establish the image in this position, and that completes the first part of the question, taking this image to here through a central symmetry in the point Q. So we're now moving on to part 2 of the question, which wants us to bring P1 to P2 by an axial symmetry. An axial symmetry is reflection across a line. So again, the first thing that we do is we join from P1 to P2. To get the midpoint of this line, you have to bisect the line, and then you draw in the bisector between the arcs where they cross, and that there becomes the axis of symmetry. So once you have the axis of symmetry established, all these points have to come onto the line at an angle of 90 degrees and travel the same distance out the other side. So the best way to achieve this is to get your set square and line that up with the line P1 to P2, and then using sliding set squares, bring C1 onto the line at 90 degrees and the same distance out the other side to get C2, and bring A1 onto the line at 90 degrees and the same distance out the other side to get A2. So the distance there that A1 travels to the line is the same distance it travels on the other side, and the same applies also there for C1. And again, you'll know you're right when you have P2, C2 and A2 all on a common line as they are up here. Okay, so once you have that done, then again, draw this image that you have up here in this location here. So once we've brought these points across the line at an angle of 90 degrees and you found P2, C2 and A2, you have the main axis going through the image. So we draw the circle, we draw the arc, and because the actual opening for the spanner is facing away from the line on this side, the opening for the spanner has to be facing away from the line on this side. So once you have all of that done, that then completes the axial symmetry, that we've moved P1 to P2 through an axial symmetry in this line here. And that completes part 2 of the question. Okay, so now moving on to part 3 of the question. We're told now that the image moves from P2 to P3 by a translation. So a translation is the movement of a point in a given direction. There's the direction over a given distance, the distance from P2 to P3. So you line up your set square there with P2 to P3 and you draw a line. You draw a line connecting those together, and then using your sliding set squares you bring C2 in the same direction and A2 in the same direction. And then you take the distance on your compass from P2 to P3, and then with that distance put the point of your compass on C2, and it is the same distance then out to C3, and put the point of your compass on A2 and swing an arc onto this line to give you A3. And this line here, the axis there that contains P3, C3 and A3, should be parallel to this axis. The image is not going to change. We're literally just going to pick up the image from here and plonk it over here. So it will be facing the same direction. So the opening is going to be on the left hand side, and it should be easy enough to draw. Okay, so P2 to P3 translation, join P2 to P3 and then bring all the other lines in the same direction. So once you've located P3, C3 and A3, you use these points to draw the figure in this location, and that completes the translation. So we have moved P2 to P3 by a translation, movement in a given direction over a given distance. Okay, so the fourth and final part of the question is to complete a rotation where we want to rotate this image. And the question says a rotation about the point O until P3 arrives up onto the line OL. So you can see there we have the line going from O to L, and you put the point of your compass there on O, you open it up here to P3 and you rotate that up until P3 comes onto this line here, giving you P4. You also rotate C3 around using O as center, and we rotate A3 around using O as center. Now if you look at this, you can see there that the angle of rotation, O is directly above P3 and P4 is on this line. So the angle of rotation is 90 degrees. That means that every one of these points must rotate through 90 degrees. And that is important for the next part of the question. So after rotating P3 up here to get P4, we now need to find one other point. So from the point of rotation, I have joined this dashed line all the way down here to A3. Now we've already said that P3 rotated onto P4 through an angle of 90 degrees. This means that A3 must also rotate through an angle of 90 degrees. So once you have your line drawn from 0 to A3, this additional line comes off that at an angle of 90 degrees to this dashed line. The best way to get that would be to place your protractor down on O with 0 in line with this line, mark your angle of 90 degrees and continue this line out until it intersects this arc, and that then gives you A4. And we know that P4 and A4 and C4 are on a line. So if you connect a line from A4 to P4, where this arc coming from C4 intersects that line gives you C4 there. Now you have your 3 points, you complete the figure. So finally, again, as we said, P3 moved to P4 through an angle of 90 degrees. So we drew a line from A3 into 0 and came off that at 90 degrees. And then when you put the point of your compass on O and rotate P3 around, C3 around, and A3 around, we locate up here P4, C4, and A4. And once you have those points located, you then draw the image in its final position after it has been rotated through 90 degrees about the point O. And this is the last part of the question. So to go through our recap, we started off with the image and we correctly found the position of all the points. And the first one there was to go through a central symmetry. So we joined a line from P to P1, we bisected that, found Q, and then brought all the points through Q, and we completed our first transformation. Then P1 went to P2, again we bisected that, we drew the axis of symmetry, the lines come onto that at 90 degrees, we found our points down here and drew the image down here. Then we had P2 to P3 by a translation, so you join from P2 to P3 and you bring the other points in the same direction, the same distance, you find P3, C3 and A3, and again you draw the figure in this position after translation. And then, as we said, we had to rotate P3 about O until it ended up on the line OL. So we've done that, we rotate the other points around, and that completes the drawing. Again, just to bear in mind the whole idea of presentation, a few little bits of information as to what you're doing, the question number, your name, the title and the date. A little bit of effort into finishing the drawing and finishing it well always pays off. Okay, that completes this question 2017, question 5.